Hello everyone! This video will introduce the configuration software setup for the NC-STT106H temperature transmitter. First, let's introduce the hardware environment. NC-SHM105 modem with a USB interface is used to provide bus power and HART signals for the product. A HART-type NC-STT106H temperature transmitter. Connect the clamp terminals of the NC-SHM105 to the corresponding positive and negative terminals of the NC-STT106. Connect the USB end to the computer. Hardware operation complete. Now open HART MPT software. When selecting a device from the list, the default address is usually 0. If you are unsure of the number of channels, you can choose to scan all channels. Select channel 0 to enter the software debugging interface. This software is multilingual, supporting Chinese, English, and Russian. Double-clicking the device list will display device information on the right. These 7 option tables correspond to different configuration information. The first page contains basic equipment information, device information, device description, long tag, long workstation number, date, manufacturer, device name, basic information such as the HART protocol version number. The second page contains basic configuration information. You can view device master variable information and set the master variable unit. Cold temp, current value now, high and low temperature alarms, and other basic configuration information. The third page is the sensor configuration interface. You can modify or view the sensor type, ring system 234, cold end compensation method, internal measurement, fixed value, 0-point calibration of a 2-wire sensor, thermocouple TC calibration, resistance temperature detector, RTD calibration, restore factory settings, save as default settings, and other sensor information settings. This is a custom page. It will not be modified by default. The fifth page is the PV value linearization calibration function. If the PV value is not displayed accurately, you can use this page. Multiple calibration points are set, and the displayed value is linearly modulated to make it closer to the actual value. The sixth page is the current calibration settings. This allows the loop current to be fixed at 3.8 milliamperes, approximately 21 milliamperes. The first click saves the settings. Clicking again restores the loop current to normal. The loop current output value can also be manually input. This section covers the loop current calibration function. There are 3 calibration methods. The first is current calibration. Select for milliamperes calibration and observe the ammeter. The actual value displayed by the ammeter when 4 milliamperes, then click apply, and it will be calibrated to the standard value. A 20 milliamperes current can be calibrated in the same way. The second step involves calibrating the loop current using voltage after connecting a 250 ohms resistor in series. 1 volt corresponds to 4 milliamperes. 5 volts corresponds to 20 milliampere. The third step involves calibrating by connecting other resistor values in series. The upper and lower voltage limits will be adjusted according to the resistance value. The seventh page is the variable monitoring interface. It mainly targets the dynamic display of variables such as PV, SV, TV, and QV. For example, the main variable PV is mapped to sensor 1. The first variable will then display the sensor's value and unit. Software interface explanation complete.